Absolute value. We often interpret that whatever is inside the absolute value bars is just positive, but it's a little bit deeper than that. There's a little more to it. Absolute value is really a piecewise function, where if the number inside the bars is positive, such as here, x is greater than or equal to 0, then it is just that number. However, if the number inside the bars is negative or less than 0, then we take the opposite of that number. So on the positive side, it is just the function y equals x when x is greater than or equal to 0. So on that domain, just greater than or equal to 0. But when y is, or x is less than 0, it's the opposite of that. So on these values, when x is the opposite of that, the absolute value of x, or y, the f of x, is equal to the opposite of whatever number we put in. So -1 outputs a +1. -5 outputs a +5. So we have that -1 slope, and we end up with a somewhat of a V pattern. Solving these equations with an absolute value in them. Anytime we see an absolute value in an equation, we have to think to ourselves, we need to do this twice. We're going to be doing twice as much work. Because once we get the absolute value bars isolated from the rest of all of the other components in the problem, the constants, when we use our properties to move them to the other side of the equal sign, we're going to have two different problems. So let's get the absolute value bars by themselves. We have to move the 2, and we have to move the 5, and we've got to change this negative to a positive. So moving the 2 and multiplying both sides by 2. Let's go ahead and do this in green. Multiplying both sides by 2 cancels the 2 in the bottom, makes us a 2 over here. So we have 5 minus the absolute value of x. Subtracting 5 from both sides gives us -3 equals the opposite of the absolute value of x. Move the negative over, we just have absolute value of x equals +3. This is the point where we have two different problems. We have x equals 3 and the opposite of x equals 3. Whatever we have on the inside of the absolute value bars is going to be either positive or negative. Once it comes out of that, once we drop those absolute value bars, then we're saying everything inside there, whatever it was, is now positive. But before we drop those, it could be positive or it could be negative. So we have to look at both cases. So in this case, it's done. X equals 3. And here we have to move the negative over, multiplying by -1 or divided by -1, or adding and subtracting each of these to the other side. So x equals -3. So our final answer here is x equals plus or minus 3, the +3 or the -3. Let me move that up so you can see it. Okay, the problem on the right. Again, our first task is to isolate the absolute value bars, and then we will divide it into two different problems. We have to move the -3, we have to move the 2. Add 3 to both sides, and we have all of this equals 3. Divide by 2. Dividing by 2, we have 3/2 equals 5x plus 1, all the absolute value of this. Now we can break this up into two problems. The positive side equals 3/2, and the negative side, negative whatever's inside the absolute value bars. Absolute value bars are a grouping symbol, so when we're looking at PEMDAS, or order of operations, these grouping symbols are dealt with in the same order or the same fashion as a set of parentheses or a radical. Alright, so 5x plus 1 equals 3/2. Subtract 1 from both sides and then divide by 5. So subtracting 1, we're going to have 1/2. Because really it's 2 over 2. Dividing by 5, x equals, dividing by 5 is multiplying by 1/5, which is going to be 1/10. That's one of our solutions. Okay, quickly now, moving the negative over, we have 5x plus 1 equals negative 3/2. Subtract 1 is negative 5/2. 5x equals that. Dividing by 5 is going to be the same thing. X equals negative 5/10 or negative 1/2. So our final answer is x equals 1/10 or negative 1/2. Okay, let's look at the examples on the bottom. Absolute value of x minus 4 equals x minus 5. Absolute value bars are already isolated, so we're going to take both cases. The positive case and the negative case. Subtract x from both sides, and if we subtract x from both sides, we have the x's canceled, so we have negative 4 equals negative 5. Even on your most favorite day of the week, negative 4 does not equal negative 5, so this tells us that there is no solution. Let's go ahead and look at the other side just in case, or just see if there's anything different. Let's see, distribute the negative here. So negative x plus 4 equals x minus 5. Let's add x to both sides and then add 5 to both sides. So 4 plus 5 is 9. Adding x cancels that x. Adding x gives us 2x. Dividing by 2, we have x equals 9/2. You know what? Just for the s and g's, we're going to plug 9/2 back into our equation. That is 9/2 minus 4 equals 9/2 minus 5. Well, this is like 4.5. 4.5 minus 5 is like negative 1/2. Can the absolute value of something, of whatever, ever equal negative 1/2? No, it can't. It always has to be a positive number. That's what we have been taught since we first started the absolute values, is that whatever this is, it's going to be positive. It can't be equal to negative 1/2. So we are set with no solution. Absolute value of 2x minus 1 equals x plus 1. Same thing. We already have the absolute value bars isolated, so we're going to divide this up into our two scenarios, where it's the 2x minus 1 and the negative, or the opposite of 2x minus 1 possibility. Equals x plus 1 equals x plus 1. Let's take a look. Subtract x from both sides, we just have x. Add 1 to both sides, we have 2. We're done. Alright, distribute the negative. Negative 2x plus 1 equals x plus 1. Subtracting 1 from both sides, well, let's go this way. We'll subtract this side, so we'll just have 1 minus 1 is, well, that's 0. And we're going to add 2x to both sides, so that's 3x. Divide both sides by 3, x equals, I'm going to write this out, 0 divided by 3, x equals 0. Sometimes it should be intuitive that to get 0, the only way we can get 0 out of a 3 times something is if that something is 0. But solving it using our normal steps, divide by 3, on both sides of the equation, 0 divided by 3 is 0. So x is equal to 0 or 2 as our final solution.